Hello students, today we are going to start a new chapter, proportion. In the last session we have learnt about the ratio. Today we are going to learn about the proportion. It is the 12th chapter of your syllabus. So let's start. So at first we'll talk about the concept of proportion. Okay, consider the following examples. Through the examples we'll understand this, that what is the ratio of the number of boys to the number of girls in a group of 8 boys and 12 girls. Here 8 will be there. Okay, 8 boys and 12 girls. So in the last session, in the previous session, we have learned that how to find the ratio. So here in the first example, it is asking, it is saying to find the ratio of number of boys to the number of girls. So we know that at first we will write the number of boys and then denominator will be number of girls. So required ratio what will be? Number of boys by number of girls. Here numerator has been written number of boys. Why? Because we have to find the number of boys. Okay, ratio of number of boys to the number of girls. So required ratio what will be? Number of boys by number of girls. It means 8 by 12. Okay, number of boys is 8 and number of girls is 12. So 8 by 12, if we will simplify it, then we will get what? 2 by 3. We will get 2 by 3. So here we have got the ratio of number of boys to the number of girls, 2 by 3. Now in the second one, it is asking that what is the ratio of rupees 18 to rupees 27. So here we have to find the ratio of rupees 18 to rupees 27. So required ratio will be what? Rupees 18 by 27. So here also if we will simplify it, then we will get 2 by 3. We will get 2 by 3. So what have we observed? That here also we have got the ratio 2 by 3 and here also we have got the ratio 2 by 3. But initially in the beginning numbers were different. Here 8 and 12 were there, but here 18 and 27 were there. Even then the ratios are same. Okay, of both the things. Here also units were different. Here the unit is rupees and we know that ratio is unitless. Got it? Because it gets cancelled. Now so we have got that both the ratios are equal in this. So here it is observed in the examples given above that the ratio is 8 by 12 and 18 by 27. Okay, 8 by 12 and 18 by 27 both are equal. It is what? 2 by 3. So both are equal. 8 by 12 is equal to 18 by 27. So here we can say that 8 is to 12 is equal to 18 is to 27. Okay, it is actually what? It is the ratio only, which ratio can be written as a fraction also, that we know. So here 8 by 12 is equal to 18 by 27. It means what? 8 is to 12 is equal to 18 is to 27. So this ratio we have got, that both the ratios are equal. So such an equality of two ratios is called proportion. Actually what is proportion? That proportion is the equality of ratio. It means if two ratios are equal, then they are said to be in proportion. They are said to be in proportion. It means they form a proportion. They are said to be in proportion when two ratios are equal. Now so here we have got that it is read as what? This is the proportion and it is read as 8 is to 12 is as what? 18 is to 27. It is 8 is to 12 and it is 18 is to 27 and both are equal. So it can be read as 8 is to 12 as 18 is to 27, and that can be expressed as like this. That it can be expressed like this. Okay, in place of equal sign we can put 4 dots. Okay, in place of equal sign we can put 4 dots, as here it has been put here. Okay, 4 dots. So here we can see that 4 dots has been placed in the place of equal sign. Got it? So both are equal. So thus a proportion is expression that which states that the two given ratios are equal. What is proportion? Proportion can be defined as that a proportion is an expression which states that two ratios are equal. Okay, two ratios are equal and this symbol is the proportion. This symbol is the symbol of proportion. Okay, this symbol is the symbol of proportion, sign of proportion. So here this already we have understood that a proportion is the expression which states that two given ratios are equal. the number 8, 12, 18 and 27 here, okay, or here both are equal. So here number 8, 12, 18 and 27, 8, 12 and 18, 27 that are used in the proportion are called its terms. So in the proportion whatever numbers are used, those are called terms. What? Terms. Those are terms. So here we can see that there are 4 terms in a proportion. Now, so this is the first term, this is the second term, this is the third term, this is the fourth term in the series. Okay, so we have got that first term here. 8 is first term, 12 is second term, 18 is third term, okay, and 27 is fourth term, as you can see here. Now in general the symbol for representing a proportion is this 4 dots, okay, this. Now sorry, so examples are given here. That example 1, check whether or not the 2 ratios form a proportion. Here we have to check that 2 ratios have been given, that 2 ratios in the question, and we have to check whether they are in proportion or not, they form the proportion or not. Then what will you do? We will check whether they are equal or not. If they are equal, it means they form the proportion. If both the ratios are not equal, it means they don't form the proportion. So we'll check. Okay, first we'll simplify the given ratios. So here the first ratio is rupees 6 is to rupees 8. So here we will get that rupees 6 is to rupees 8, then 6 by 8, it means 3 by 4. So the value of first ratio is 3 by 4. Now we'll simplify the second ratio. 12 kg is to 16 kg is equal to 12 by 16. Kg will be removed, okay, in the ratio. So 12 by 16, and if we will simplify it, then it will be 3 by 4. So what have we got here? That we have got the value of 6 is to 8 is 3 by 4, and the value of 12 kg is to 16 kg is 3 by 4. It means the value of both the ratios are equal, that is 3 by 4. No, it means both the ratios are equal. It means if both the ratios are equal, it means they form the proportion. Okay, ratios 6 is to 8, ratios rupees 6 is to rupees 8 and 12 kg is to 16 kg are equal. It means they form the proportion. So like this we'll check in the second question also. So the first ratio's value is 2 by 3. Okay, 6 kg is to 9 kg, then 2 by 3, and 10 meter is to 16 meter is equal to 5 by 8. So here we have got that the values of both the ratios. Okay, the value of first ratio is 2 by 3, the value of second ratio is 5 by 4, 5 by 8, sorry, okay, 5 by 8. So here we have got that both the ratios are not equal, both the ratios are not equal. So ratio 6 is to 9, okay, 6 kg is to 9 kg is not equal to the ratio 10 meter is to 16 meter. It means they don't form the proportion. So we have understood that when the 2 ratios will be equal, they will form the equation. If they are not equal, then they don't form the equation, sorry, proportion. So some important points are there, that in a proportion the first 2 terms, okay, must be of the same kind. Here one thing we'll have to keep in our mind, that first 2 terms, okay, or quantities must be of the same kind and of the same unit, whereas last 2 terms must also be same kind, of the same kind and of the same unit. As we have seen here, that in the first ratio, okay, both are of the same kind, okay, these are represented in the rupees, units are same, and here also units are same. It means in first 2 terms are same, of the same kind, and units are also same, and last 2 terms are also of the same kind and units are same here also. Okay, so this thing we'll have to keep in our mind, that whenever we are going to find the ratio, then ratios, what, the terms should be of the same kind and of the same unit. So this thing we'll have to keep in our mind, that first 2 should be of the same kind and of the same unit, and last 2 terms also should be of the same kind and of the same unit. Now second point here, all the 4 quantities in a proportion may of the same kind and the same unit. Yeah, for all the 4 quantities also may be of the same kind, no problem, but first 2 and last 2 must be same. Okay, first 2 should be same kind of and second 2 should be of the same kind. Now second point, we'll just focus on the second point now, that in a proportion the first and the fourth terms are extreme terms. in the proportion, first and last, it means fourth terms, are known as the extreme terms, and second and third are called the means. Okay, or middle terms also is these are called middle terms or means. So here if we will talk about, suppose that this is the ratio. Okay, this is the ratio. Suppose the proportion A is to B is proportional to C is to D. Suppose that this is the proportion, then first term is A and last term is D. So A and D are the extreme terms. A and D are extreme terms. What? Extreme terms. Extreme terms. So first and last terms, first and fourth terms are known as extreme terms, and the middle terms, wait, C is to D, and these second and third terms are known as means. What? Second and third terms are known as means or middle terms. So I hope that you understood that first and fourth are extreme terms and second and third are means or middle terms. And one more thing, important point is there, that product of extreme, okay, product of extremes or extreme terms is equal to product of means terms. If the ratios are in the proportion, if they form the proportion, then the product of extremes must be equal to the product of means. Suppose that this is the proportion A is to B is equal to D, C is to D. Okay, this is the what? Here we can say that if A is to B and C is to D, okay, they are in the proportion, then the product of extreme terms, it means A and D, okay, A into D, the product of extreme terms must be equal to product of means, it means C is to D. So it must be there if they form the proportion. Okay, if they don't form the proportion, then it will not be equal. Got it? And in this, suppose that A is to B is equal to C is to D is there, then here D is known as the fourth proportional. What is D is known as fourth proportional. Now example, some examples are there that check whether the whether or not the given ratios form a proportion. Here we have to check whether they form a proportion or not. In the first example also we have done that we had checked that they form the proportion or not, but the method was different, that we have simplified the ratios and we have seen that simplified value is same or not. If the value was same, it means they form the form the proportion. If values were not equal, then they were not in proportion. So here we'll learn a different method, and different method we'll use to check whether they form the proportion or not. Okay, first one is there that we'll simplify, that we have understood. Now second one is there that we'll just get the product of extreme terms and means. Okay, product of extremes is equal to 15 into 56, and here 840, and a product of means 24 into 35, and that is also 840. So here we have got that product of extremes is equal to product of means. Product of extremes is equal to product of means, and we know that if this condition will come, then they form the proportion, because it is possible only when they form the proportion. Okay, when product of extremes is equal to product of means, it is in only one condition, when the ratios form the proportion. So here these are equal, it means the ratios are in the proportion. Okay, so in the second also we can do the same thing. We will get the product of the extremes and the product of the means, and we will check whether they are equal or not, and here we can see that they are not equal. Okay, product of extremes is equal to not equal to product of means. It means the given ratios do not form the proportion. So two methods we have got, that and this formula we will use, product of extremes is equal to product of means, to check whether the given ratios are in the proportion or not. And one was there that will simplify, and then we'll compare are they equal or not, and then we can say that whether they form the equation or not, proportion or not. Now yeah, example is there that numbers 8x 9 36. Okay, one x is there, we have to find the value of x here. It is saying that numbers are there, four numbers are there, which 8 x 9 and 36, sorry, and they are in the proportion. So we have to find the x. If they are in the proportion, then what will be here, that they are in the proportion, it means 8 is to x is equal to 9 into 30, 9 is to 36. It means what should be there, that the product of extreme terms should be equal to the product of means. If they form the proportion, and it is saying that yeah, they are in the proportion, it means here the product of extremes, it means what, 8 into 36 is should be equal to product of means, it means x into 9. So we have to find the value of 9. So it's sorry, x. So 9 will be shifted this side, so x is equal to what will be 8 into 36 by this will be transferred this side, then it will be in division, so 9. So 9 4 ja, then x is equal to 8 into 4, it means 32. I hope that you understood that how we have got the value of x. If you not understood, then rewind the video and try to understand again. So in the second question, the same thing is there. We will find the value of x using this method. What, the product of extremes is equal to product of means, and we will simplify. We will get the value of x here. Now example 4, that find the third and fourth terms of the proportion. So okay, the first, third and fourth terms are given. First, third and fourth terms are given. We have to find the second term. Okay, second term is missing, it is not given. Okay, so we have to find the second term. They are in the proportion. So suppose that the second term is x. Okay, let the second term be x, then what will be 12x. Okay, x is the second term, that's why it is placed at the second place. So 12x, 8 and 4 are in the proportion, that is 12 is to x is equal to 8 is to 14. Okay, now we have got, now we can do that product of the means is equal to product of the extremes, and here x is equal to what, it will be transferred this side, then it will be in division, and if we will simplify it, then we will get the value 21. So we have got the value of x 21. And what was x? X is the second term, it means second term is 21. Second term is 21. So simply we will consider x. Okay, if any term is not given, and we will simplify this using the formula that the product of means is equal to product of extremes. Okay, now example 5, the same thing is there. You will do the examples. Okay, you have to practice the examples yourself. Now we'll talk about the continued proportion. Here that three terms, okay, three terms A, B and C of all the same type and in the same unit. All the quantities should be of the same type, okay, and in the same unit. Okay, then three terms A, B, C are said to be in the continued proportion when A is to B is equal to B is to C. Here try to understand that numbers are only three. Okay, A, B and C, only three quantities are there. The ratio of first two, okay, the ratio of first two quantities and the ratio of second and third quantities should be equal. Then we will say that they are continued proportion. Okay, they are in the continued proportion. So I hope that you understood that what is the continued proportion. If three quantities are there, then the ratio of first two, okay, first and second, and the ratio of second and third should be equal. Then they are said to be in the continued proportion. Here the repeating term is B. Second term is being repeated in both, so it is the repeating term, and it is known as the mean proportional. Okay, it is B is known as the mean proportional here. The repeating term is known as the mean proportional here. Okay, which is in between the A and C. And the third term is C, and here the third term is C. Here you will not say that the third term, it is the fourth term. No, it is not the fourth term here, because the this one quantity is being repeated here. So in this condition, in the continued proportion, this is the first term. Okay, this is the mean proportional or repeated term, and this is the third proportional. Okay, this is the third proportional. Yeah, term is fourth only, but the third proportional. Now if A, B and C are in the continued proportion, A, B and C are in the continued proportion, then what will be this condition? Same thing is written here. Then what is there, that A is to B, it means A by B is equal to B by C. if we will do the cross multiplication here, then b into b is equal to a into c. Okay, b into b is equal to a into c, b into b is equal to b square, and ac into, okay, a into c, it means ac. Here we have got that b square is equal to ac. If we find the value of b, then a square will be removed, okay, then it will come this side, then it will be converted into the square root. We know that whenever we transfer the power 2, then that will be converted into the square root on the another side. So b is equal to root and ac. Earlier ac was there, so now power has been transposed, so now root ac. So if three terms are given like this, three terms are given, then easily we can find the mean proportional. What? Mean proportional or repeated term easily we can find. The formula is there that mean proportional is equal to root under first term into what? Third term, a into c. Now example is also given. Here we have to find the mean proportional. So this is the first and third term, okay. So let the mean proportional be x, okay. So we have supposed that mean proportional is x. It means what will be that 1 by 18 is to x is proportional to x is to 1 by 8, okay. Now x into x, okay, product of the means term, okay, means is equal to product of the extremes. Here we have got that x into x is equal to x square is equal to 1 upon 44, okay, it will be multiplied, then 1 is 1 and 18 is 144. So here we have got that x square is equal to 1 by 144. If we solve it, okay, it is missing here, sorry, okay, I am telling you that what will be the value of x. X will be root under 1 by 144, okay. Power will be transferred this side, then it will be converted into root, then x is equal to root under 1 by 44, and we will find the square root. We know that how to find, then we will get the value 1 by 12. This is the answer. You will practice these examples. It is very, the examples are very important. So here also we have to find the third proportional. Here two numbers are given, okay, two numbers are given. So don't think that this is the first term and this is the second term. No, it is not the means, it is not the second term. Here we have to find the what? Third proportion. Yeah, so we do, sorry, here it is the first and it is the second, okay. We have to find the third proportional. So suppose that third proportional be x, so what will be there, that 15 rupees 45 and rupees x are in the continued proportion. Here rupees x is written. Why? Because all the three terms should be of the same kind and of the same unit. That's why here also we have taken the unit rupees. Now so all these will be in the continued proportion. These three rupees 15, rupees 45 and rupees x, they are in the continued proportion. That is the ratio of first and second term is equal to the ratio of second and third. So here if we solve it, okay, we will just, what is the rule, that the product of the extremes 15 into x 15x, and the product of means, it means 45 into 45, it means x is equal to 15 will be transferred this side. Then if you solve this, then you will get x is equal to 135. How? X is equal to, you will get 45 into 45, okay, and this 15 will be transferred this side, then by 15. So 15 3 is 45. If you multiply 3 and 45, then you will get 135. So x is equal to 135 we have got here, okay. So I hope that you understood these things. So this was the last example of the chapter. So I hope that you have understood all the concept of proportion. So you practice, at first you practice all the examples. Examples are also very important, because examples are also the questions only. So practice all the examples and then do the exercises. Now you can do all the exercises of the proportion chapter. All of you, bye, have a nice day.